Hello children, welcome to this segment of the program. It's mathematics time, and that means it is fun time. Hi, I'm Uncle Agbaje. Today in mathematics, we will be looking at angles and the measurement of angles. But before that, the correction to your previous assignment. Number 1 says the product of 9 and a number is 108. Of course, you know that product means to multiply. So the equation we will use for this is 9 times n equals 108. In this case, n is 12 because 9 times 12 is 108. Number 2 says the sum of a number and 11 is 19. Of course, you know that sum means addition. So that means that I add 11 to a number, I will get 19. Of course, in this case, n is 8 because 8 plus 11 is 19. Number 3 says 7 more than 3 times his age is 58 years. How old is he? Now, 3 times his age to begin with is 3a. 7 more than that is to add 7 to 3 times his age. So you have 3a plus 7 is 58. And if we solve this using the way that we have been taught in our previous lessons, we'll get 17. But just to be sure, 3 times 17 is 51. 51 plus 7 gives us 58. The last question says, the age of a father is 10 more than twice the age of his son. Now, if the age of the father is 54, how old is the son? Now, we need to know twice the age of the son. In this case, that is 2a. Now, 10 more than twice is 10 more than 2a. That is 2a plus 10 gives us 54. If we solve using the normal way that we have been taught in our previous lessons, we'll get that the a is 22. But just to be sure, 2 times 22 is 44. 44 plus 10 is 54. Now, I'm sure that a lot of you did this well, and for that, you deserve a cheer. Moving on to the objectives of today's lesson. By the end of this lesson, you should be able to recognize acute and obtuse angles, right angles, and straight line angles. And I can assure you that if you pay enough attention, after this lesson, you will not have problems differentiating between acute angles and obtuse angles. Of course, you have the right angle, we should be able to identify, and then the straight line angle. Then you will be able to measure angles using the hands of the clock. So let's just move right into it. Usually, we are told that angles is the meeting point of 2 lines. When you have 2 lines come together like this and they meet, you say, this is what you call an angle. The lines have to join to each other. Now, to get a better understanding of angles, we usually think of angles as the total distance moved by a line that is moving around a circle, just like this line here. It moves round, and then as it moves, an angle is formed. As it moves farther, the angle increases. Okay? The farther the distance, the more the angle that is covered. So in this diagram that you're going to see here right now, you will see that B has moved to A, but A has moved to M. This distance is a very small distance. It has moved from here to here. That is little distance. But from here going to M, that is a larger distance, and that means a larger angle. That is why angle AOB is smaller than angle AOM. It's quite easy to see. The distance is larger than this one. Let's move on. Now, I want you to stand up right now. Go to the door of your sitting room or your room or wherever you're watching this lesson and close the door. I believe you have done this. When you have the door closed, no angle is formed. Now, open the door slightly, then you have a little angle. Open it wider, then the angle increases. Open it wider, then the angle increases. Open it all the way, and you have a much bigger angle. I believe you all did this. Now let's look at some more applications of this. This is like the door opening wide. Now, when the line moves around the circular path and goes back to the starting point, of course, your door cannot do this. I mean, in most cases, your door can only open 1/4 of the way. But if you're able to get a line that starts from here and goes all the way around, then it's going to have to start again, much like the hands of your clock. By the time it goes round, we say it has traveled 360 degrees. This is just a mathematical convention that mathematicians have agreed upon. Much like the ants of your clock, when it starts from 12, goes to 1, then an angle is formed. Goes to 2, a bigger angle. Goes to 3, a bigger angle. Then it goes all the way. Then it has formed 360. And then it goes round again. That's another 360. So one thing you need to keep in mind is that when a line moves around a circle, 360 degrees have been formed. Moving on. If the line goes just halfway, I'm going to let you do this. If the line goes just halfway, like from here down to this end, like from 12 down to 6, it didn't go all the way. As you can see, it has divided the whole path into 2. If it goes half of the way, then how many degrees do you think that's going to get us? Because if the full way, the full distance gives us 360 degrees, then half of that is just going to give us 180 degrees. And this is what we call the straight line angle. It's a very important angle, so you have to keep that at the back of your mind. Full circle, 360 degrees. Halfway around the circle forms a straight line, and that is 180 degrees. So you can start from anywhere. If you're starting from here, then by the time you get to this place, that's halfway round the circle. If you're starting from here, by the time you get here, that's halfway round the circle. The straight line doesn't have to be this way. It can be this way, it can be this way. Any straight line from one end to the other end is always 180 degrees, which is half of 360 degrees. And that is the straight line angle. Moving on. If it goes 1/4 of the way, not all the way, just like this is half of the way. Now, this is half of that, and that is 1/4. And as you can see, this angle divides the whole distance into 4 equal parts. Now, if it goes 1/4 of the way, all you have to do is just divide your 360 into 4. Okay, I have to go 360 steps, for instance. Now, I've gone 1/4 of the way. That is 1/4 of 360, and that is going to give you 90 degrees. Now, this is a very important angle in mathematics. You will find the 90-degree angle almost everywhere around you. You find it at the corner of your book. You find it on top of your ceiling. You find it on the tiles, on the floor. You find it right at the corner of your TV set. You find it everywhere around you. It's a very, very important angle. We call it the right angle. And we usually mark it with a box. We don't write the name for the angle. We just put a box in the corner. So whenever you see a box in the corner of any angle, just know, oh, that's the right angle. Now, what's the value of the right angle? That is 360. You have divided it into 4. The whole distance divided into 4. And that is 90 degrees. You don't need anybody to tell you that after today. Moving on. Now, all the other angles now follow suit. Some angles are smaller than 90. Some angles are bigger than 90. Let's look at these angles. Obviously, they are smaller than 90. Look at this one. From here to 3 is 90 degrees. But this angle has not even gotten to 3. So that means it is smaller than 90 degrees. Perhaps it's maybe 45 or even 40. But it is less than 90 degrees. This one is also less than 90 because here to here is 90 degrees. And this is smaller than that. This one is also smaller than 90 degrees because from here to here is 90. This is also smaller than 90 degrees. Now, we call these angles that are smaller than 90 degrees, we call them acute angle. Now, do you want to know why they call them acute angles? I'll tell you. When something is acute, it is sharp. If you use a sharp object to prick yourself, it can cut you. Much like these angles that you have here, you can see that the end points are very sharp. The end point very sharp. If this is the end of a knife, it can hurt someone. They are sharp angles. That's why we call them acute angles. So if acute angles confuse you and you cannot remember sharp angles, and that is a smaller angle. Let's move on. Angles that are bigger than that are not so sharp. This cannot be the end of a knife, so it's not sharp. It can't cut you. We call these angles obtuse angles. When something is obtuse, it means it is blunt. And an angle cannot be blunt unless it is bigger than 90 degrees. So all these angles are bigger than 90. Of course, you know that 90 stops here, 1/4. So this is already more than that. It has gone beyond 3. It has gotten to 4. Also, 90 stops here. So this one has gone beyond that. It is above 90. They are obtuse angles. The same applies to this. The same applies to this. All these angles that you see here are obtuse angles. Eyes on me. Now it's time for the second activity, and for this I've had to remove my jacket. So you can drop your pens and stand in front of television sets. We're going to play the making angles game. Now, you put your hands beside you like this and observe my arms and my body as well. Ensure that there is no space between your arm and your body. If there is no space, then there is no angle. Now, we're going to form acute angles. And how do we do this? We'll raise our hands a little bit. Ha! There is a little space. There is a little angle. If I close it, no angle again. Open it, an angle. Now, I want to increase the acute angle. I raise my hands a little bit. Ha! A bigger angle. Now, I need to increase that acute angle. A bigger angle. The more I raise it, the more the angle. Now, if I want to form the right angle, the 90 degrees angle, I have to raise my hands until it is parallel to the floor. Now, the angle between my arm and the rest of my body is 90 degrees. Lower than that, it's an acute angle. Right angle. Put your hands at shoulder length, that is the right angle. Now, if I want to form obtuse angle, guess what I'm going to do? Am I going to lower it? No. I'm going to raise it higher than 90 degrees, higher than the right angle. So this is an obtuse angle. Right angle, obtuse angle. A bigger obtuse angle, even bigger obtuse angle. Now, I'm going to make my hands straight. This is no longer an obtuse angle. My arm is now straight with the rest of my body. This is the straight line angle. This is the straight line angle. 180 degrees. 90, 180. 90, 180. Anything in between obtuse. 90, zero angle. 90, zero angle. Anything in between, acute angle. Thank you for participating in this stretch up with me. Now we're going to play a little game to see how far and how well you've understood the concept of angles. You're going to guess the magnitude of these angles. How many degrees do you think this is? You have 5 seconds. 1, 2, 3, 4, 5. This is the 90 degrees angle, of course. It is 1/4 of the circle. I'm sure you got that right. Let's move on to more challenging ones. How many degrees do you think this angle is? This is obviously bigger than 90, because 90 should stop here. So you have 3 seconds. 1, 2, 3. This is the 120 degrees angle. I hope you were close. Let's take something more challenging. How many angles do you think this is? Obviously, this is, do you think it's less or more than 90 degrees? It is less than 90 degrees. But how many do you think it's going to be? Let's take the answer. It is 50 degrees. Were you very close? Good job you then. Let's move on. How many degrees do you think this is? Is it more than 90 or is it less than 90? You have 5 seconds. 1, 2, 3, 4, 5. Answer to this. This angle is more than 90 degrees. In fact, it is 100 degrees. Good job you. The numbers on the clock face actually divide the whole 360 into 12 equal parts. That means that in between 12 and 1, there is an angle. But what is the magnitude of this angle? If I divide the whole 360 into 12, I get 30 degrees. So between 12 and 1, there is 30 degrees. Between 1 and 2, there is 30 degrees. And so on like that. 30, 30, 30 in 12 places, I get my 360. All right, moving on. Let's see how we can apply this to solve some real problem. Example 1 says, what is the angle between the hands of the clock right now? Well, as we have said in the previous slides, between each number, there is 30 degrees. So from here to here, 30 degrees. From here to here, 30 degrees. From here to here, 30 degrees. There are 3 spaces. So which means I will multiply 30 by 3 and we get 90 degrees. 30 times 3 is 90 degrees. So this is my final answer. Let's look at something a little bit more challenging than this. The question says, what is the larger angle? And you need to be very careful when you get here. There are 2 angles actually. The smaller one and the bigger one. So you have to calculate the bigger angle. All you have to do is just count how many spaces this way, and you get your answer. Let's go. From here to here, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 spaces. Now for each space, there is 30 degrees. So that is 30 in 8 places. You have 30 times 8, and you get 240 degrees. One final example. What is the smaller angle between the hour and the minute hands of the clock? This is the hour hand, and this is the minute hand, so we do not need this. We're interested in the smaller angle, not the bigger angle. And so we go from here. 1, 2, 3, 4, 5. There are 5 spaces, and that is 30 degrees multiplied by 5. You will get 150 degrees. Important thing to note, when you're doing a question of this kind, do not subtract the smaller number from the bigger number. It doesn't always work. The best is that you count physically and multiply. Take a look at the exercises in the next page and see how many of these you can get right. You have just 1 minute. Begin. Eyes on me. Now let's look at the correction. Here we have 150 degrees because you have 1, 2, 3, 4, 5. 30 in 5 places, that is 150. Here we have 120 degrees. 1, 2, 3, 4. 30 in 4 places, that is 120 degrees. Here we have, let's go, 1, 2, and then you have half. So for this 1 and 2, that is 30 in 2 places. That is 60 degrees. Now this is just half of the whole thing. Half of the whole thing is half of 30, and that is 15. So from here to this point is 15 degrees. If you add 15 degrees to 60 degrees, you get 75 degrees. So note that this has not gone all the way. It has only gone half, and that is just 15 degrees. Here is a straight line. It doesn't need calculation, but if you count, you will get 1, 2, 3, 4, 5, 6. 30 in 6 places is 180 degrees. And of course, the straight line angle is always 180 degrees. How many did you get? I hope you got all. If you did, then you deserve a chair. Now we've come to the end of this section of the program. I want you to copy this and do them during your leisure. I advise you to take a camera phone and quickly snap them because you may not have enough time to copy. I will now hand you over to Uncle Popo for the General Studies class. Till I come your way next time, remain wonderful mathemagicians.